So today we're going to talk about quantities, SI units, and prefixes. And we'll also discuss how to set up some conversion factor index cards so that we can do dimensional analysis problems in the next lesson. So measurements, let me get to my drawing here. When you take a measurement, you need a number and you need a unit. Measurements represent quantities. And so a quantity has to have magnitude, size, or amount. And so some examples of quantity and measurements. So if you have a quantity would be volume. And a measurement would be a teaspoon. So quantity and measurements are not the same. I do want to go back up here and highlight this part about units. If you just take a measurement and just give a number, say you just say 5.0, well, you have to have a unit. It's important to determine if you're talking about, for example, speed. Are you talking about miles per hour or kilometers per hour? If you're giving me a volume, are you talking about milliliters? Are you talking about teaspoons? You have to give a unit with your number for measurements. So let's talk about mass versus weight. And let me put some space into my paper down here. Give me just a second. I don't want to do that. Nope, I don't want to do that. Turn that off. I want to do this. There we go. Okay, so let's talk about mass and weight, two different quantities. So mass first, we'll look at mass first, and then we'll compare it, and then we'll look at weight, and then we'll compare the two. Mass is a measure of the quantity of matter. The SI unit, and we're going to look at SI units today. The SI unit for mass is kilograms. And it's abbreviated kg. You measure mass on a balance. And so in lab, we have triple beam balances. We have electronic balances we would use to measure the mass of an object. And when we talk about derived units later this week, we'll measure the mass of some objects and find their volume to find density. We then want to look at weight. And so weight is a measure of the gravitational pull on matter. It changes as gravitational forces change. And so this is measured on a spring scale. Whoops. Should say spring scale. So let's compare mass versus volume on the moon. Mass versus weight, excuse me, not volume. Mass versus weight on the moon. So if you were to travel from the Earth to the moon, your weight on the moon is 1/6 your weight on Earth, because the gravitational pull on the moon is less. However, your mass is the same. It does not change with your location. So mass, whatever much matter, it does not change with location. So now what we want to do is look at the SI units. This is a figure in your textbook that I'm pulling up. It's figure 2.1. It's page 38. Just a few things we'll go over. Length is the meter. You notice that you have the quantity. Let me highlight these. You have the quantity, you have the symbol, you have the unit name, and the unit abbreviation. And then there's a standard. This is how we define the quantity, how we measure it. The length of the path traveled by light in a vacuum during a time interval of so many seconds is a meter. So that's how we define the standard for this quantity. So length, the unit abbreviation is meter. For mass, the unit is kilogram for the SI unit. Time we would measure in seconds. Kelvin is the SI unit for temperature. We will use the mole for the amount of substance. And then electric current and luminous intensity are ones you would use when you move on to physics. Let me erase that. So then prefixes. This is another figure in your book. This is figure 2.2 on page 39. Now, depending on which class you're in, will determine how many of these you need to know. So here in the middle, so you have your prefix, your unit abbreviation, the exponential factor, the meaning, and then it gives examples. In the middle here, where it's 10 to the 0, it says meter. This is your basic unit. And so you could have meters here as your basic unit. You could have 1 liter. You could have 1 gram. And those are all basic units that you would go back to. If you are in regular Chem 1, you need to know the ones I circle here in red. You need to know kilo, hecto, deca, basic unit, deci, centi, milli. And I'll show you a mnemonic device on page 25, and then I also have another mnemonic device if you don't like the one in your book. If you're in my honors class, you need to also know micro and nano. You need to add on those two as well for your prefixes that you should know. And we will use these in class in dimensional analysis to make changes from convert from one unit to another. These at the top are large units, and then at the bottom are smaller units, if you notice, compared to the basic unit. And when I teach you how to do these conversions, say from milli to kilo, we always would go milli to the basic unit and then to kilo. If you can go directly from milli to kilo, that's fine. But I will always show you by referring back to the basic unit. So on page 25 is this mnemonic device. I'm going to give you another one. Maybe you have your own from another class, but the one in your book, and this only goes from kilo to milli. So if you're my honors class, you would have to have a way to add in the nano and the micro to your mnemonic device. So this one is King Harry drools ugly dark chocolate milk. The one I use is King Henry declared ugly dudes can't marry. That was the one I have. So whichever one works best for you is the one that I would use. So one of the tools that I would like to use in class is index card, conversion factor index cards. And so on your materials list, it said that you needed an index card. And so you don't have index cards, you can cut up square sheets of paper and use those. And so these are just a tool to help you. And one of the assignments, if you're watching this at home, is to make these cards. And so here's my index card. And this is the front. And this is the back. And so on the front, I'm going to do my conversion from kilometers to meters. You're going to do all of the conversions. So I'm just going to go 1 kilometer is 1,000 meters. And then on the back of that card, so I don't waste index cards or waste papers, I would do 1,000 meters is 1 kilometer. And so when we do the practice at home or in class, depending if you're remote or in class, you can get out these index cards and put them in the problem as we're working through them. And so on the front, so then you would want to do like kilo to hecto, kilo to deca, kilo to deci, kilo to centi, kilo to milli. So I'm going to write a note down here. If you are in my, oops. Oh, no. Go back here. Sorry for just a minute. So if you're in honors, your index card should be kilo through nano. And if you're in regular, your index card should be kilo through milli. And we'll use these when we do some practice in class. If you're in my full remote class, then we'll use these as we go through the practice that we're going to do in the next lesson. If you have any questions or concerns, please see me in class or send me a message in Schoology. Have a great rest of your day.